So let's go ahead and get started. We have a section on web apps in action, and it's something near and dear to my heart. I think we have three great presentations. So as usual, and I've asked everyone so far, please mute yourself and turn off your video. As we always say, everything will be recorded, so you can pick it up later. And I think that's about it for the opening. First up, we have Steve Hossack, and Steve is going to present on spatial analysis integration with IBM Watson. Steve is a GIS software architect for Maricopa County. He has a bachelor's and a master's degree in civil engineering from Arizona State University, and he has over 25 years of experience with GIS in both public and private sectors. His extensive background includes GIS application development, geospatial database design and administration, and enterprise system architecture and systems integration. He has applied GIS technology to many fields, including transportation, public works, environmental, water resources, public health, and law enforcement. And with that, Steve, take it away.
Okay, thank you, Jeffrey. So first of all, I'm using my phone for audio, so hopefully it doesn't cut out. I've been told that that's kind of the safest approach for audio. But if you guys can't hear me, just speak up, or if I cut out, just let me know. I assume everyone can see my presentation, so I'll just kind of move on. So good afternoon. My name is Steve Hossack. I'm a GIS architect with Maricopa County. For this presentation, I'm going to discuss spatial analysis integration with IBM Watson. Okay, this integration effort with the chatbot was done for the Maricopa County Clerk of Superior Court. The clerk's office was established by the Arizona State Constitution to serve the citizens, legal community, and the Superior Court. They handle such things as appeals, marriage licenses, passports, and many others. The clerk deals a lot with the public and has 9 locations throughout the county. Our technology solution partners over at the clerk's office include Richard McHattie, Chief Technology and Innovation Officer, who is a champion of innovation for customer engagement. Also, Aaron Judy, Technology Innovation Strategist, who was our primary contact and led the team on the clerk side. Here's a listing that kind of illustrates the amount of workload that the clerk takes on. On average, over 36,000 pieces of paper are filed each day. They process more than 43,000 passports annually. Every year, they issue more than 22,000 marriage licenses. Their electronic repository has over 65 million scanned images and growing. So as you can see, they have a huge workload running on limited resources. In addition, they must have staff interacting with customers for inquiries and submitting forms, scheduling appointments, and other in-person meetings. One of the biggest problems they run into is poor customer experiences. This is caused by many things, such as long waiting times, in person and on the phone, lack of parking at downtown offices, lack of information about what services are available and at which location. One common complaint about doing business with the clerk is that it might take up an entire day just to kind of do a simple transaction. So the Chief of Innovation and Technology decided that what they should look into is a chatbot. A chatbot is capable of online conversations, and it could be a way to decrease the amount of interactive voice response calls and provide a greater customer experience. Because the chatbot had to be capable of a few things: natural language experience, it had to adapt, and it had to implement machine learning and artificial intelligence to kind of know what people were talking about. It needed to be spatially aware so that it could help customers or help the chatbot determine locations to provide customers locations and directions to facilities. It had to sort of be a virtual subject matter expert. And finally, a chatbot must also not be a dead end. It should never run out of solutions and then stop. It should always, at the very end, if it can't solve the problem, at a last resort, hand it off to a human to handle the inquiry. You might have experienced chatbots at various company sites before. Another tactic of improving customer relations is to provide spatial capabilities, such as a web map. So the clerk came to the GIS group and discussed these 4 major requirements. They wanted a web mapping application, which they never had before, that could run on multiple platforms, web, mobile, tablets, stuff like that. The ability to provide routing and directions for driving and walking, integration with a chatbot, and data layers that can show on the map court locations, parking, transit services, and real-time traffic conditions. So based on user requirements, we investigated all available technologies to design a viable solution. Here are some key specifications for our design. First of all, at the top there, top bullet point, we used Web App Builder for ArcGIS. We decided it would be best to host it on our county on-premise servers to utilize our standard gis.maricopa.gov domain. Because we use Web App Builder, the app is mostly configurable, but there were some custom widgets that we definitely needed to be made. First of all, for connecting to the chatbot and displaying driving directions. One great feature about Web App Builder that we discovered is the ability to initiate application behavior by submitting parameters in the URL. Shown in the center here, there's some sample parameters shown for the URI. So the URI basically takes you to the Web App Builder application, but based upon these parameters, it will do things like the first one will find a customer service center. The second set of parameters will provide driving directions based upon the supplied origin and destination. Also, we definitely used Arcgis Online. The county, Maricopa County, has an enterprise AGOL agreement, so we needed it for a few items here. One, to kind of host some feature layers for like parking locations, court locations. We used AGOL, the routing service that came with it, and it also provides real-time traffic conditions as well. So here's our GIS solution architecture. This was a collaborative effort with the IT group over the clerk of the Superior Court. And the good thing about that is we're all connected together behind the firewall. So all of our servers and everything talk to each other. Illustrated on the left is the system that the clerk hosted, and it was IBM Watson, among other things that aren't shown here. But Watson basically is the brain behind the chat. It basically receives short text messages and processes them and routes them to different functionality. It also learns how to properly respond to inquiries. Over on the right-hand side is basically our GIS infrastructure. And of course, we have sort of like this hybrid on-premise and cloud architecture, meaning that we use AGOL for a few items, but we also host the application because it provides custom widgets and services. So we used AGOL. Once again, it had a lot of good features like routing, real-time traffic, and stuff like that. And then on our server, on our on-premise server, it hosted the GIS application and the custom widgets and services. One of the great benefits of using Esri's Web App Builder is that it supports a variety of client devices. It sort of has this responsiveness. So it can work, on a desktop browser, which is shown here kind of on the left-hand side. This is what it looks like on a browser application. On the right is a screenshot of how it looks in the iPhone. Yeah, this is iPhone. That was my iPhone. Anyways, it should work in Android too. So it just kind of shows that with Web App Builder right out of the box without a whole lot of configuration or customization, you know, this will go ahead and work on multiple devices. Okay, the integration of spatial awareness with the chatbot required an interface to GIS functionality. The great thing about using ArcGIS Server is that there's a lot of REST API calls available for use. The following REST API functions that were used include authentication, so that it generates a token, so the client can get access to a lot of other host features and services. Search for an address based upon the user input through the chat or a web app. Route to closest location, so the user can be sent to the closest court facility based on their input location. Generate route and directions that guide the end user to a facility. And these links down here kind of show you examples of how to use the REST API, how to kind of accomplish these tasks using these functions. So here's an overall solution illustrating all the different systems involved. The spatial awareness component of the solution is shown in the bottom center. All the other systems and technologies that you see here, all the other stuff, was implemented by the clerk of the Superior Court IT team. The specifics about these other systems are beyond the scope of this presentation, but I want to show you how, I want you to illustrate how everything kind of fits together. As shown, Python scripting is the glue that kind of binds IBM Watson with the spatial functions. Over on the left side kind of shows how messages can be sent to Watson through voice assistant devices. And then over on the right kind of shows the path of messages coming in through keyboard through a chatbot. So let's see the solution in action. So right now we have a major outage, internet outage over at Maricopa County. So I went ahead and embedded a couple of videos. So hopefully they'll show up for you okay. This first one, I'm going to show you a video of a user entering information through a chatbot. So they open up the chatbot and they type in, "I need directions," and the chatbot responds and says, kind of confirms their request. They say yes, and then the chatbot asks for an address. So the user supplies an address, and then the chatbot takes that and then asks a couple more questions right here. They just want to check to see if they know which facility they want to go to. The user enters the Downtown Justice Center, and then it confirms kind of their address. And then I want to stop it right about here and notice that it does a couple of things. First, it confirms with the user that their origin and destination are correct. Then it provides a hyperlink that will open up the web map and display the driving directions. Finally, there's a bottom message down there. It says the closest facility is actually the Southeast Regional Center and gives a distance and travel time. So that's useful too. Even though they specified they want to go downtown, it still gives them, you know, information about what's closest to them based upon their location that they provided. So let me go ahead and restart this. Okay, so the user is going to click on the map, and it's Web App Builder, so give it a minute or a few seconds, and then comes up, and then it shows on the map, kind of shows a map of the routes and provides driving directions. But then the user wants to ask, you know, more questions. So we have a chatbot built into the web application as well. So they said, okay, well, you mentioned the Southeast Center. So what's the wait time? So the user enters in information about the wait time, and then the chatbot responds back and tells them, based upon the type of service, what the wait time is, and the number of customers that are waiting. So the next demo I want to show you is I'm going to do something kind of unconventional here. So let me turn off my video. Hopefully everything will work out okay. I'm going to turn up my speaker because there's some audio with this. So hopefully this works.
What is the closest facility to me?
Would you like to determine the nearest location?
Yes.
What is your street address only? Example, 123 North Main Street.
301 West Jefferson Street.
Okay, you are searching for locations nearest 301 West Jefferson Street. Performing spatial analysis. The closest facility to 301 West Jefferson Street is the East Court Building at a distance of 0.18 miles and a driving travel time of 1.13 minutes. Is there anything else I could assist you with?
Okay, so that illustrates interacting with this application through a voice assistant. And then if you want, there's a YouTube video here that you could watch some more examples of this in action. So that's kind of everything that I have. If you have any questions, provide it now. Otherwise, feel free to email me if you have any follow-up questions. So thank you.
Thank you, Steve. That was really interesting. I don't see anything in the chat window. I did have an initial question for you, which is what service you were using for driving locations, but then I think you answered that. I changed that to your ArcGis REST calls for returning the driving locations. That's going against Maricopa County network data, right? So you guys maintain a network for that service?
No, we use a third party.
Okay.
Yeah, so we use we have, we definitely have centerline data, but I think that third parties kind of do a better job of maintaining networks, for routing and stuff like that, and real-time traffic and stuff like that. So we use, basically what's provided to us by Esri.
Okay. So still don't see any more questions, but if anybody has any, you can type them in the window and maybe Steve will keep an eye on that. Otherwise, please contact him at the information. I'm going to send the presentation over to Josh. Josh is our second presentation, Josh Pope. Josh is the Technical Services Administrator at Pima Association of Governments, where he focuses on guiding his team to deliver content and tools to support data-driven decision-making processes. And Josh is giving us a presentation on God Open Services. What reports? We got widgets for that.
Thank you very much, Jeff. So we'll get into the wonderful world of widgets soon, but I want to begin with the demonstration of a tool set that we deployed 3 years ago in support of our recently adopted 2045 Regional Mobility and Accessibility Plan update. Let's see. This platform and content were developed in-house by an amazing team of application developers, GIS experts, transportation modelers, and planners. PAG implements performance-based planning across the board, and we'll be focusing on our RMAP long-range plan and how this approach is integrated into our 5-year TIP program. The 2045 RMAP is in alignment with FHWA Fast Act performance measure requirements, and these are some of those categories that we'll be focusing on with this presentation. In the plan, we've established goals and targets for 54 detailed performance measures. We have a regional system overview of these PMs, and it's available in this dashboard. But in this presentation, we're going to jump into a demonstration of the RMAP web toolset that takes performance measures to the project level and puts them in the hands of our jurisdictional partners as they explore, review, and create projects. So we're going to jump first into the Project Explorer. With the RMAP web, it's an update. So we have hundreds of existing projects from a previous plan, from our previous 2045, and we're going to add some performance data into it. So some of the examples of this is pavement data for system performance. So we've aggregated our IRI data for the region, our bridges for the region, and another emphasis area is safety. So we have a level of safety service built off of our SPFs that we've made available, and our current and future modeled congestion for intersections and roadways. So these are kind of those three kind of emphasis areas for system maintenance, safety, and system performance described down below in this assessment grid. When we click on a project, this one in particular, the web map will zoom into it, the area, but you can kind of see at a high level glance in this executive summary that this extent of the network is poorly performing under safety and current and future roadway, not to mention the sidewalk presence and environmental impact. We have a report of content supporting this high-level grid. When you click on View Report, you open up, and what you're seeing here is the cover page of a 10-page document. You have that assessment grid across the top, and on the left-hand side, we have the data related to each of the emphasis areas, performance areas, and then on the right-hand side, you kind of have that assessment criteria. So what does an IRI of 154 mean? Well, it means that it's fair. So on and so forth as you step through the different emphasis areas. We'll get into the other pages of this report in a sec. Jumping back into the site, this is useful kind of explore the individual project, but when you stack up these assessment grids against each other, that adds a little bit more value. So we have a project review page where we can see this. And as we start to kind of build out that in-plan project list, and we want to make sure that we're emphasizing safety, so we can sort by the intersection and roadway safety, and make sure that the projects that have been identified are going to make it to that in-plan list. There's that Orange Grove project we looked at. We're going to jump into another one on Ina Road and look at, when you click on that, it'll zoom to the extent, but it's also going to bring up that 10-page report. So this report, starts with that assessment grid, but it kind of it shows you the work. It shows you the backstory to what's contributing to these PMs. We have that pavement condition across the top. Overall it's in fair condition, but you can see in the map that the west portion of the extent is in poor. It can also show you where those poor bridges are on the extent of your project. Each one of these pages supports that little grid element up top, right? So this is the safety, level of safety service. We get to describe what LOS is and where we built our SPFs and all the background. But it also shows you that the full extent of that corridor isn't equally. The middle portion is where we really want to pay some attention. And we're also pulling in the safety, this finer resolution safety content, individual level, collision manner, and so forth. For system performance, we have current, future volumes and congestion. And this may feel similar to a data-driven page or a map, an old-school map book, and that's exactly what this is, right? It's this feature extent for this Orange Grove project, and we have dozens and dozens of attributes associated with this extent. Here's the sidewalk presence. We have 17% sidewalks in this extent, so that puts it in the poor category. And for environmental impact, it's cutting across an important riparian area. So we want to make sure that's flagged. Freight reliability, 3.93. What does that mean? It means it's fair. So kind of that data value and then that assessed condition. And then we have func class and bike facilities. Actually, the functional class was our first one we had in order to get the predominant feature. So that kind of gives you the overall view of what that 10-page report does. Now we're going to show you how to create a project. Our partners created new projects in addition to reviewing some of their existing ones. And we're going to do it in a different platform because our RMAP exercise, we don't want people to submit new projects, so this is kind of a sandbox. We're going to create a project based on a safety emphasis. So we're going to zoom in, and this is going to show you how you can go in and digitize an extent and get that content at your fingertips. So we're going to focus in on this level of save LOSS4 area, asking you to draw a point or a line. Tells you how to draw a point or a line. Click once to begin it. and double-click to end it. And so this custom extent is taking that geometry that you just digitized and going and inspecting those REST endpoints and pulling this data out of from our portal, essentially from our Arcgis server. So we have all of this content, current, future volumes, bike ped volumes, project congestion for that specific area. If you're interested in saving this, you need to name it, give it a title and description so you can find it in our saved projects list. Once you save it, it's going to go out and build those map images, those blobs that we're going to store into our table of the map for those supplemental pages. The data had already been acquired to build out the rest of the numbers, but capturing those images just occurred in that cycle. So in under 20 seconds, you can have this custom 10-page PM report. Click on that, search for your name, open up that Word document, and it will show you that custom report. This is actually going to show you that Ina Road one, but here it takes Word a little bit to open up, and you see the new report demo, and it gives you some of these high-level metrics that you're interested in, and then gets you into that deep dive. All right, so and you can kind of tell this is similar to that data-driven page, but so what in development of this, we built out all these rules, we built all these conditions as they align with our long-range plan goals and objectives. So one aspect of this process, it was a long-term process. We needed to be able to update our project list because we had new data, we had new transportation data model runs. Travel demand model runs that we're going to have fresh data. So we wanted to do a bulk assessment. So we exposed this tool where we could drop in a REST endpoint and identify the unique identifier. And it goes and it consumes that REST endpoint and steps through the features, the geometries of that endpoint, and does that assessment of all those different metrics and pushes it out to a CSV. This is useful not only in the execution of our iterative process with our RMAP, but it's also useful as we're looking to see how our 5-year TIP program aligns with these performance goals and objectives of our larger umbrella long-range plan. So we are able to drop in our TIP feature services just as easily as we're able to drop in these long-range plan feature services. We'll open up the CSV and scroll across. I don't expect you to really understand the 110 attributes here, but that's what was just produced in roughly 40 seconds for 46 points on our network. So that's our bulk assessment. That content is then handed over to our graphics team to show what are those package impacts of that group of projects. So that's been really helpful as we look to implement this. So I shared with you our long-range plan and our 5-year programming, but we want to be able to do some specialty plans and build new rules. And so we went towards the widgets to kind of make it easier to build out rules on available data. So we're going to step into a set of assessment widgets. These are all within Web App Builder. So you open up Web App Builder, you start layering in your custom widgets. So we have a rule builder, which will build the rules. A report builder, which will allow you to compile collections of those rules. And that's our create new project widget, and that's our bulk assessment widget. So you can go step through those last two functions. You also need a web map. This web map I based on federal data, but I should have based it on the AZGeo open data. This is the National Transportation Atlas data sets. I plowed all that data in there, and we published the site. And we're going to look at the Rule Builder widget. So the first thing you need to do with the Rule Builder widget is point it to your rule library. And this is just a feature service. This is an editable feature service in a portal. This can be on anybody's portal. This is on our portal. One thing I want to do right now is pause it and breathe. I did not step through the next step in the Rule Builder is you need to name it and give it a description. And then you click on Select Condition Layer. And when you click on that Select Condition Layer, this pop-up shows up. and it goes and inspects your table of contents. And it gives you all the layers on your table of contents. And in this example, I'm selecting the fatal motor vehicle incidents. You can see this geo.dot.gov REST endpoint that we're going to then inspect with this rule that we're about to build. So I may have dwelled a little bit too long there, but once we name it, once we select the feature service, the condition layer, we can start to report a summary statistic. We're going to report that summary statistic on the fatal field attribute in there, and we're just going to want to get a sum. We just want to get that total. We can add a map image with that layer to our report and have that descriptive text sitting underneath it. Here's a second rule, flood hazard zone. You can see down below in the middle here, it's based on a FEMA REST endpoint. And we're going to want to build a query into this. This is an old school query builder here for flood zone AE. And we're building a rule that tells you if more than 1% of this project area is within that flood hazard zone AE. You can add a map of this and add descriptive text. A third rule that we are going to step through is going to be looking at the Hpms principal arterial feature service from that INTAD directory. This particular rule looks at volume, that AADT of those principal arterials. The next set of rules are going to be dwelling on that principal arterial REST endpoint. This is looking at max speed, and this is looking at pavement condition. Good old IRI, we're going to do an average, but then we're going to add some thresholds to tell you what's good, fair, or poor. All right, with our collection of rules built out, we're going to kind of pull them together into a report. Similarly, you're going to go and point to where your rule library is, where your report library is located on your portal. And those are just those feature services, editable feature services with appropriate schema, but nothing super special. And then as you start building out your report, you see your available rules on the right-hand side. You just drag them into the selected rules, and it starts kind of composing that cover sheet grid. And if you have more than 2 assessed condition rules, it's going to start building out that assessed condition grid across the top. So now that we have this looking the way we want, we can save this report into our report library, and then we can use this as we create a new project to get that high level, or to get that report. So let's step through that. So here we are, create a new project, create assessment project. We go to our report library, select the principal arterial report, and we're going to draw a line. This is down in Tucson near the airport in I-10. What you're seeing here is that HPMS principal arterial REST endpoint color-coded to the pavement, and you should see where the results come in. And I'm just going to continue with this breakneck pace and jump all over the state to Sierra Vista and start digitizing some extents to show you that, you know, this can move beyond. This is defined by the extent of your data. So hitting federally available or state available data sets, these rules can apply to them anywhere. And goes and pulls a summary. We see that's in fair condition, 8,000 AEDT, 55 miles an hour, and 2 through lanes. We're going to jump on up into Tempe and step through the similar exercise. This data, so in this one, we're going to kind of pick an area that has a little bit of red going on. So we can see beyond some just fair pavement conditions and run this performance summary. And on any one of these, if we want to save it as a project, we could have saved it as, but here we go. It is in poor condition. It's 204. There's 30,000 volumes. And jump up to Flagstaff for our last Arizona view of that principal arterial. So clearly, we could be adding any other REST endpoint. In the 110 attributes that we're evaluating, that represented about 30 different feature services that we've built out within to support our RMAP. But here, the pavement is good. Volumes are 22,000. Speed limit's 40. And since it is that FHWA data set, we can move beyond the confines of the state, even though within the web map that I built this, I put a definition query on it. It doesn't matter, so you're not seeing the displayed. I actually just zoomed in, clicked on what appeared to be a principal arterial, and just to see what the results, and you can see that Arizona is doing a much better job than California, because they're missing 2 of the 4 elements, but here it does show you that that pavement is at 148 and is in fair condition. So that is a kind of a demonstration of that create project widget. I'm going to finally step through that bulk assess, and we're going to add in REST endpoint of the fatalities for 2018. We're going to add a definition query. We're only looking at the ones in Pima County. Pulled in 117 results for 2018, and then give us that unique identifier, select the report that we want, and then execute that principal arterial condition so that we can go and get the speed limit, the volumes. Here's the ADT, the volumes, the through lanes, and it's a weighted average of through lanes for that geographic extent. And then pavement condition where available, that is the value, average value, and the assessed, and then the speed limit. That query actually takes a good bit longer, but anyhow, for the purposes of today, I want to say thank you for joining me, and if you have any questions, I'd be happy to answer them.
Wow, thanks, Josh. That was a lot of information. But thank God for modern technology. We can all go back and revisit this because there was a lot of good stuff there. So it looks like most of your stuff was written as ASPX projects, C# or VB.NET. At one point you said you were accessing web services. Is that right?
So we're certainly leveraging the JavaScript API with that custom built stack. Yeah, and that was kind of that source of this, and then we migrated into the widget realm, and that has a lot of pain points that my developers would love to go into details on, but but that makes it much more accessible. The web services that we're hitting are just the Esri REST endpoints.
Yeah. Okay, I don't see any questions, but again, like before, if you have any, please either send them to Josh. He's got his contact information up, or type them into the window. Maybe he'll keep an eye on that while the rest of the session goes. We only have one more presenter, and I think I'm going to pass it to Sage.
Yep, that'll be right.
Okay. All right. Mm-hmm. Oh, gotta look at my other screen. Okay, so you should be presenter, and I think
no problem. Good afternoon.
Carol, are we going to try to have Carol talk at the same time?
Yeah.
I have just a little bit to contribute, yes.
Okay. So
Awesome.
next up, we have Sage Donaldson and Karol Francis, and they're going to present different types of data visualizations. How are they used? Sage is a GIS analyst for the Arizona Department of Transportation, working specifically as the Highway Performance Monitoring Systems, or when I was at Adot, we affectionately called that HPMS. Analyst in the Data Analytics Group. Her daily work spans anywhere from producing and assisting in data visualizations to coordinating with local agencies to gather data for reporting purposes or mapping transportation GIS data. Sage graduated from the University of Arizona with a degree in environmental studies in the School of Geography and Development in the winter of 2018. So Sage is still new in her career, but very excited to be part of the Arizona GIS community. Karol Francis is a GIS analyst with Gis Incorporated, a contractor for Adot. which is essential in the creation of Adot's dashboards. With that, I'll leave it up to you.
Awesome. Thank you so much. I really appreciate everyone listening in. We're really excited to give this presentation. Again, my name is Sage Donaldson. I'm a GIS analyst and the HPMS analyst for Adot. With me today to present is Karol Francis, and we'll go ahead and get started. So before we get into it, just real quick an outline of how we're going to go through this. We're going to talk about what exactly data visualizations are, and then go through 2 ways that we've used data visualizations in dashboards and story maps, and then briefly talk about why we think data visualizations are as important as they are. So real quick before we get into the actual applications here, the core of data visualizations as far as the transportation goes and in the ways we've used it really comes down to visually appealing, easy to use, easy to consume data, whether that be in a map format, a tabular format, or information as in like a text-based format. Another really important aspect to it is the manipulation of that data source to gain information and understanding, and also be able to use these data visualizations, graphs, maps, whatever they might be, in order to make data-driven decisions. These are also, sorry, I'm trying not to breathe so loud on this. These are also really useful when it comes to training purposes, as they're incredibly interactive and use live and up-to-date data that you can really get your hands on and get in the weeds with. So we're going to talk through the dashboards first here, and we've used 2 different dashboarding applications, one being Tableau and one being the ESRI operations dashboards. So these, regardless of the software, are live and up-to-date and easily manipulable data. The point behind it is to be able to give users or consumers of the data the option to filter and manipulate that data in the dashboard the way they need, whether it's MAG needs to see the functional classification, or MAG needs to see all of the Maricopa County owned structures that are poor condition or anything like that. It's a really important aspect to this. It also offers that authoritative data source and trustable data source. They're easily accessible. They're incredibly interactive, as we've talked about previously, zooming in on the map, going in and selecting different things, and really allows you to work with the data rather than having to email people around, and just accessible to data, or making the data usable for a plethora of people. So I'm going to pass it off to Karol for a sec.
Sure. Thank you, Sage. So basically my goal when building these dashboards was to make the vast quantities of ADOT data accessible to non-GIS users and people who aren't necessarily comfortable with numbers or large data sets. Next slide, please, Sage. Okay, so we're going to demonstrate 2 dashboards. The first one is an Adot structures dashboard, and I built this dashboard using Tableau. Go ahead and open that dashboard, Sage.
Let me see if this works. Oops. Sorry, the switch in between the remote desktop. Can everybody see this dashboard?
Now I see it, yes. Okay, so here is the Adot structures dashboard, and it has 4 tabs. The first tab, the landing page, just basically describes the dashboard and has a data disclaimer. It also contains a link to YouTube tutorial for how to use a dashboard and a link to the metadata dashboard that contains metadata about the dashboards themselves. So this tab here is the structures performance summary. Every year a bridge is inspected and rated, good, fair, poor ratings, and this summarizes the structures by year. And all the little widgets on this tab are interactive, so the user can choose to show performance ratings for all years, no years, just view, go ahead and hit all. So we have the most data here. And if you want to see, like Sage said, all structures that are rated poor, if you click on the red in the pie chart, it will give you a breakdown of the deck area of poor structures in the state. And as you can see, the poor rating has decreased over time, which is great. doing a good job of maintaining our bridges in Arizona. So go ahead and open up the HPMS dashboard now. The HPMS dashboard that we're going to demonstrate was built using Esri Operations Dashboard, which I loved. I thought it was fantastic because Tableau is wonderful for showing anything your heart desires as long as it's not spatial data. And Esri Operations Dashboard sort of fills that hole and really is wonderful with visualizing spatial data. And so this is HPMS Dashboard, and go ahead and zoom back in. It's a little bit buggy because we need to do a little bit of optimization on it, but all the widgets also interact with each other. You can choose to zoom into an MPO cog, so we could look at MAG if we wanted to. And that will adjust the zoom is so funky on this. You might need to zoom in the map a little bit. But it shows the vehicle miles traveled, centerline miles, and lane miles of all roadways that are within the MAG boundaries. And if you just pan and zoom the map, all the totals change as you move around. And the map is misbehaving a little bit and being a little bit slow today. But you get the idea that it allows a non-GIS user or not really a non-data person to be able to get a snapshot of what's going on with our HPMS data. So go ahead and sure. Back to you, Sage. Thank you very much.
Awesome. Thank you, Carol. So we'll go ahead and we'll move on to the story map portion of our data visualization talk. So before we kind of dive into it, just kind of a background on what story maps are. There's been so many awesome story map displays and presentations. I don't know that this is terribly necessary anymore, having been through the conference, but essentially what it boils down to is a well-flowing narrative featuring high-level information or data-centric information in a easily consumed way and visually stimulating way. So I'm going to talk about kind of the ways that I have used story maps for Adot purposes, and I break them into 5 different categories. Metadata, analysis, training, tutorials, and visualizations being combining story maps with other types of visualization products. So for metadata, oftentimes metadata can be very dull and very in the weeds, and so putting this into story map context allows you to really get a high-level perspective on it and also be able to interact with the data from within it rather than reading a text page and then trying to flip back and forth and understand it. You can really look at it right when you're in it. For analytical purposes and analysis purposes, it allows you to show an entire scope of project or an analysis that was done and read through it and understand it while also interacting with the data at each level of the project. Training purposes are fairly straightforward, but using story maps to allow people to learn how to do something or how to operate something while also showing them the data while moving along through it is very helpful and very important for hands-on learning. Tutorials in story maps make it really, really easy to share the platform with everyone, whether it be local agencies or internal staff and whoever it might be. And lastly, visualizations allow you to have the story map embedded with a dashboard or a survey 123 or a collector or whatever it might be, and allow you to explain everything that's happening within it and then also manipulate the data from the dashboard or other application. So I'm really quickly going to go through just an example of each of these real quick. So for starters, I'm using this junction story map that we put together. And if you can see this picture here, this is our traditional metadata standard. And then this is the story map that we put together, or that I put together, in order to really dive into this and make it a more digestible version of metadata. And so here we're talking about what it is. You can dive into the map immediately. We've got some really good visuals of everything, explaining it, and it's told in the narrative of which you would learn the exactly what junctions are and the importance of them for transportation and HPMS purposes. So that's how we've used an example of metadata. For our analysis and project purposes, this is a story map detailing the process of our federal functional classification rebalancing project that we went through last year. And so this one is really interesting because it includes all the information necessary. So the background, what functional classification is, a map so you could look into it and understand it better, the issue, the reason why we needed to do this, what the actual process was, walking through each step of the process in here, this being a visual analysis, this being what was given to local agencies, a map to better understand it, and then the actual approval of it. And then again, the result breakdown and everything, and overall conclusions of it, and allowing us to, to embed a URL in here so that if a user came and found this and read through the implications of the rebalancing, they could also go in and then put in a functional classification change request, having just read this. So then I'm going to go through these two just real quickly here. So this is just an overview of the highway performance monitoring systems, key elements in it. I think this is a very good example of a possible training story map. So if someone was new, I know not everyone is terribly familiar with HPMS, but the idea of giving that very high level key element aspect to really complex information is a really good way to consume the information in story map form. With tutorials, a really cool thing that I kind of wanted to show. This is our tutorial for how to upload traffic counts to the MS2 Tcds system, the traffic count system. And one of the things that is really cool is each local agency has their own type of traffic counters. And while you're reading through this on how to upload your counts, you can then navigate to your specific traffic count software, read about how to format the data in order to be able to upload it, and come back to here and begin uploading. And lastly, we're going to look at, just real quick, oh, you know what? I forgot I had it right here. One of those visualization context ones. So in here I have embedded this structures dashboard. This is one of those operations dashboards that Karol was talking about earlier. And so if I needed to come in here and learn, or find information about Apache County data, let's say I need to know what is qualifying them to have so many poor ratings, I can come in here and manipulate the data here, and then also go and understand why it might be rated poor. So what actually goes into the ratings per se. And so having the story map linked right in here, where I can come through and immediately find the information that I need for why bridge condition might be what it is, and then navigate right back to the dashboard to do what I need to do in manipulating the data. So lastly, I just kind of want to go over why we find this really important and why we want to use it as much as possible. And so really the biggies is using these, providing these dashboards and story maps and visualizations in general really allows users and consumers of the data to make data-driven decisions about whatever project or anything else that they might be doing. It also makes it usable for the masses. So rather than an analyst from Yuma County emailing 10 people to try to get information on functional classification, it's easily available and easily manipulable to whatever they might need. There's a ton of other great importances to as you can see here, but those really are the biggies, as well as making that metadata more visually stimulating and more easily to consume overall. So with that, that is the end of our presentation. Thank you so much for everybody listening in. If there's any questions, I'll go ahead and answer them now, but otherwise, thank you so much.
Well, thank you, Sage and Karol. That was another awesome presentation. That's another wealth of information. I saw you had a listing of those sites, and we could easily go and check those out by checking out your presentation. Or is there another location for us to get this listing?
Yes. Along with that slide, you can also go to the Data Analytics Adot website. And down here at the bottom, I have the list of all the story maps that I've showed in this presentation, as well as many more, if you're terribly interested in them.
Well, thank you. I'm putting one last call for the questions. At this point, we're not going to be taking any more in the chat window. Put it in the link for the survey. Please take a little bit of time after this to write down what you liked. If there was anything you didn't like, I don't know if we have any of that. And after this, we have the hospitality suite. It's Tiki night. So that'll be 4:30 p.m. Thank you all for presenting, and thank you all for being here.